All right, hey guys, biology students. I wanted to help you out, give you a little bit of work through here of the first problem for your homework tonight. I believe this is homework 10.5. We're taking a look at crossing over, and again, it's helpful. Hopefully, it's helpful for you guys to kind of see how to do some of these problems. So I'm going to work through the first problem on this homework with you. So here's the homework. Hopefully, you guys have had a chance at this point to kind of read through it, take a look at it. And again, if you're confused, you're not sure what you're doing, hopefully that's why you're here. And hopefully I can help. All right, so we have a homologous pair of chromosomes. Now again, the idea with crossing over is that you're actually going to have a ton of genes on any one chromosome. So each of these letters represents a different gene. Gene A, gene B, gene C, gene D, all the way out to gene P. So we've got a lot of different genes on this one chromosome. And that's definitely possible. Remember, the average human chromosome has about 800 genes on it. So just A through P is probably not nearly enough, but we're going to work with it. We're not going to draw 800 different genes. All right, now the nice part about these chromosomes is that they are homologous. We're looking at gene A. Both of them have gene A, but they're also heterozygous for everything. So you notice how the top chromosome here, the lighter chromosome, has all lowercase letters, so has the recessive allele, and the dark chromosome is dominant for everything. So these two chromosomes are completely heterozygous. All right, so number one here, we're going to have crossing over occur, and then here's the first thing. Our top chromosome and our bottom chromosome are never going to change. They're always going to be the same. So I'm just going to go ahead and start. Question number one here. I'm going to go ahead and start with my top chromosome, A, B, C, D, E, F, G. Have a little break right there. That's the center. And then H, I, J, K, L, M, N, O, P. All right, barely fit across the page there. Now that I got my letters, I'll go ahead and kind of draw the chromosome. All right. Now the next chromosome. This is where crossing over is going to occur. The problem here, number one, tells us that crossing over is going to occur at point 2. So I took a look at point 2. Point 2 is between C and D. So it's going to be in the same location up here between C and D. So if crossing over is occurring right there, I'm going to keep my ABC lowercase. So chromosome number 2 here. ABC is still lowercase, but then we have that crossing over occurring. So that means it's going to change genes with the dominant chromosome. So after lowercase a, lowercase b, lowercase c, now I'm going to have dominant B, dominant E, dominant F, and dominant G. Now we're just going to keep on going. Do we have another crossing over? Single point of crossover? Nope. So that's it. Basically, we're exchanging the entire back half of this chromosome with the top one. So I'm just going to keep on going with my dominant letters here. And actually, I believe these two connected. They are sister chromatids with one another. Maybe kind of connect there. And there we go. That is our first chromosome. You can see because of crossing over, we've exchanged genes. It was a chromosome with all recessive or lowercase genes on it. Now we've got a chromosome with some lowercase genes and some uppercase genes. So we have completely invented this whole new chromosome. This is a chromosome that this individual, whatever species this individual is, whoever this is, this individual now has a chromosome that they did not inherit from their mom, nor their dad. This is a completely new chromosome with kind of mixed genes on it. So definitely provides for some unique genetic combinations, some completely unique genetic combinations. Same thing on the bottom now. So this chromosome, the darker chromosome, is going to start off with capital A, capital B, capital C, but here's where it crossed over. So it's now going to have the lowercase d, lowercase e, lowercase f, lowercase g, lowercase h, lowercase I, lowercase j, k, l, m, n, o, and p. So again, this is where a crossing over occurred. That was point 2. This is where those chromosomes exchanged pieces. So that's where our crossing over occurred. They changed pieces there. My bottom chromosome then, just like the top one, the bottom one is not involved in crossing over, so it's just going to stay as all capped letters. And again, we'll combine them there in the middle. So we've got our X-shaped chromosome there. And again, we now have completely unique chromosomes due to crossing over. We were supposed to just have capital A, capital B, capital C, capital D, all capital letters, but now we've got some capital, some recessive. We have a completely new combination of genes that can be passed on to the offspring in this particular organism. So that is problem 1. Well, that's 1A, I suppose. 1B then asks, list which genes have been exchanged with those on its homolog or neighbor chromosome. Well, genes D through P. Were exchanged. So we exchanged genes D through P. And that's how we do question number 1. When you get down to question number 2, you have to kind of think through for yourself here. We have 2 crossing overs occur. So the first crossover will occur at point 6, then it'll cross back over at point 7. So this one will go like capital, 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 then lowercase, lowercase, capital, capital again. And same thing up here, that double crossover will be mostly lowercase with just a handful of uppercases. So see if you guys can't figure that out. That's your homework for this evening. Hopefully this video was helpful. If not, I hope to see you either at office hours this afternoon or resuscitation on Friday afternoon. Come to one of those two if this video didn't give you what you were going for. Have a good afternoon. I'll see you guys on Monday.